Ensign George Gay is floating in the water. He is 25 years old, a pilot with Torpedo Squadron 8 off the USS Hornet. For the last hour, he has been hiding under a loose black seat cushion, the only thing keeping him from being strafed by Japanese Zeros. He is the sole survivor of his squadron. All 14 of his fellow Devastator torpedo bombers have been shot out of the sky. From his vantage point in the water, bobbing in the swells, Gay watches the turning point of the war. He sees American SPD Dauntless dive bombers scream down from 15,000 feet. He watches as 1,000-pound bombs smash into the flight decks of the Japanese carriers Kaga and Ezekagi. But beneath the heroism and the explosions, there is a terrifying mechanical reality. The Devastator Gay flew was a death trap, slow, heavy, and obsolete. It was built in the mid-1930s, when aluminum was scarce and aviation technology was in its infancy. The Dauntless dive bombers that just saved his life, however, were different. They were lighter, stronger, faster. Their skin was stressed aluminum alloy. Their frames were extruded duralumin. Every single maneuver that saved the American fleet at Midway depended on a specific metal. A metal that, just 18 months prior, the United States did not have enough of to build even a fraction of the air force it needed. The planes that won Midway were built with metal that didn't exist in American stockpiles when the war began. This is the documented story of how R.S. Reynolds, a foil salesman from Kentucky, challenged a government-sanctioned monopoly, mobilized 30 million American housewives, and turned the kitchen scrap of a nation into the wings of victory. It is the story of how America solved the aluminum paradox to save the free world. In 1940, the United States was the greatest industrial power on Earth, yet it possessed a fatal Achilles heel. The modern war machine, specifically the fighter plane and the long-range bomber, had an insatiable appetite for aluminum. Steel was too heavy, wood was too fragile. Only aluminum offered the strength-to-weight ratio required for high-speed aerial combat. But the numbers were terrifying. In 1939, Germany was producing 195,000 tons of aluminum annually. The United States produced only 148,000 tons. The Luftwaffe had been stockpiling the metal since 1935, building a reserve that allowed them to churn out Messerschmitts and Heinkels at a rate the Allies could not match. The crisis wasn't just about production capacity, it was about raw materials. Aluminum does not occur naturally in a pure state. It must be refined from bauxite ore. In 1940, the United States imported 60% of its bauxite from Dutch Guiana in South America. The shipping lanes from the Caribbean to American ports were infested with German U-boats. By January 1942, just weeks after Pearl Harbor, the situation was critical. U-boats had sunk 22 bauxite carriers in the Caribbean basin. President Roosevelt called for the production of 60,000 aircraft in 1942 and 125,000 in 1943. It was an impossible order. The War Production Board calculated that the aircraft industry would need 1.4 billion pounds of aluminum in 1942. The projected supply was short by nearly 400 million pounds. Without that missing 400 million pounds, 18,000 aircraft would simply not exist. There would be no escort fighters for bombers over Germany. There would be no replacement planes for the carriers in the Pacific. The deficit wasn't just a number on a ledger, it was a death sentence for Allied strategy. The United States faced a monopoly problem as well. For 50 years, the Aluminum Company of America, ALCOA, was the sole producer of primary aluminum in the nation. They controlled the bauxite mines, the refining patents, and the smelting plants. While efficient, a single company could not scale fast enough to meet the sudden, explosive demand of a two-front global war. The bottleneck was absolute. America needed a second source, and it needed a miracle of recycling to bridge the gap until new factories could come online. Enter Richard S. Reynolds Sarn. Born in Bristol, Tennessee, in 1881, Reynolds was not a metallurgist. He was a salesman, a visionary, and the nephew of tobacco tycoon R.J. Reynolds. He had made his initial fortune making lead foil for cigarette packaging. But in the late 1920s, he saw the future. He saw aluminum. Reynolds founded the U.S. Foil Company in 1919, which later became Reynolds Metals. He was obsessed with the material's potential. He famously said, "I want to see aluminum in every kitchen in America." He introduced aluminum foil to the American housewife, replacing the heavy, toxic lead foils of the past. By 1938, Reynolds Metals was a successful fabricator, buying raw aluminum ingots from ALCOA and rolling them into sheets and foil. But Reynolds was uneasy. In 1937, he traveled to Europe to scout for new sources of raw aluminum. What he saw in Nazi Germany chilled him to the bone. He toured factories where aluminum production was running 24 hours a day, 7 days a week. He saw the massive stockpiles. He saw the single-minded focus of the German state. He returned to the United States and went straight to the government. He warned the War Department that ALCOA's production capacity was woefully insufficient for the war he knew was coming. He was ignored. The prevailing wisdom in Washington was that the current supply was adequate for defensive needs. Reynolds didn't wait for permission. In a move that nearly bankrupted his family, he mortgaged all 18 of his existing factories to secure a $15 million loan, roughly $315 million in today's money. He wasn't just going to roll aluminum anymore, he was going to make it. He purchased land in Sheffield, Alabama, near the Tennessee Valley Authority's hydroelectric dams. Aluminum production requires massive amounts of electricity, and Reynolds needed cheap power. He broke ground on the Lister Hill plant in late 1940, months before the government finally acknowledged the shortage. Reynolds was 60 years old. He was fighting a monopoly that had crushed every competitor for half a century. He was fighting a government bureaucracy that didn't believe him, and he was fighting time. When the Japanese bombs fell on Pearl Harbor on December 7, 1941, Reynolds was the only man in America with a new aluminum plant ready to come online. But he faced a new, terrifying problem. He couldn't get enough bauxite ore to feed the furnaces. The U-boats were winning the Battle of the Atlantic. The crisis of 1942 required a two-pronged technical solution: find a way to refine lower-grade domestic ore, and find a way to reclaim aluminum from the civilian population. Both presented massive chemical and metallurgical hurdles. First, the refining process. Aluminum is produced using the Bayer process to create alumina, followed by the Hall-Héroult process to smelt the metal. In the Bayer process, bauxite is crushed and mixed with a hot, concentrated solution of sodium hydroxide. The aluminum oxide in the ore dissolves into sodium aluminate, while the impurities, primarily iron oxides and silica, remain solid and are filtered out as red mud. The problem facing American engineers was silica. The high-grade bauxite from Dutch Guiana was low in silica. Domestic American bauxite, found in Arkansas, was high in silica. In the standard Bayer process, silica reacts with the caustic soda and the aluminum to form sodium aluminum silicate, a hard, glassy scale that clogs pipes and, more importantly, consumes the expensive caustic soda and wastes the aluminum. For every pound of silica in the ore, you lost a pound of alumina and a pound of soda. Using Arkansas ore in standard plants was chemically inefficient to the point of uselessness. ALCOA and Reynolds engineers had to develop a combination process. They added a sintering step. After the initial digestion, the red mud, waste, which still contained significant lost aluminum due to the high silica, was mixed with limestone and soda ash, then roasted in a rotary kiln at temperatures exceeding 2,000 degrees Fahrenheit. This sintering recovered the alumina and caustic soda that the silica had trapped. It was a complex, chemically delicate add-on that turned waste back into resource, allowing the U.S. to utilize millions of tons of Arkansas ore that had previously been considered dirt. But mines take time to dig, and factories take time to retrofit. The immediate gap had to be filled by recycling. This led to the second technical challenge, the pot and pan drives. Recycling aluminum for aircraft isn't as simple as melting down a soup ladle and pouring a wing spar. Kitchen aluminum is typically soft aluminum, alloy 100 or 3003, which is nearly pure aluminum with a little manganese. Aircraft aluminum is hard alloy, specifically 2024 duralumin, which contains precise percentages of copper, magnesium, and manganese. If you mix a random assortment of pots, pans, cigarette foil, and lawn furniture into a furnace, you get an unpredictable, Mongrel. Alloy. If that alloy has too much iron, it becomes brittle. If it has the wrong grain structure, it will fail under the catastrophic G forces of combat. Metallurgists had to develop a system of sweetening the scrap. The collected civilian aluminum was melted into large heats. Samples were drawn and analyzed using spectrographic analysis, a relatively new technology that used light refraction to determine chemical composition in minutes rather than days. Once the exact impurity levels were known, pure virgin aluminum and specific hardeners like copper and magnesium were added to the molten bath to dilute the impurities and bring the alloy up to military specifications. It was a massive chemistry experiment conducted on an industrial scale, turning millions of heterogeneous kitchen items into a homogeneous, precipitating hardening super metal. The Aluminum for Defense drive officially launched in July 1941 and accelerated wildly after Pearl Harbor. It was a logistical operation that rivaled the mobilization of troops. Mayor Fiorello LaGuardia of New York City became the face of the drive. "Give us your aluminum," he bellowed over the radio. "We will turn your pots into pursuit planes." The targeted goal was 20 million pounds of scrap aluminum. The scale-up relied on a decentralized army. The Boy Scouts of America, the Girl Scouts, and local air raid wardens became the collection agents. In Chicago, designated Aluminum Days saw children piling mountains of cookware on street corners. In small towns across Nebraska, movie theaters offered free admission for a pound of aluminum. But the real crisis was at the sorting and processing plants. Reynolds Metals and other secondary smelters were overwhelmed. The scrap arriving was a nightmare of contamination. Handles on pots were made of steel or bakelite. Rivets were iron. Some aluminum items turned out to be chrome-plated steel or zinc. At the Reynolds plant in Louisville, Kentucky, the workforce transformed. With men drafted into service, women took over the sorting lines. It was grueling, dangerous work. They stood for 10-hour shifts next to roaring furnaces, manually identifying and removing non-aluminum contaminants before the metal hit the crucible. The heat in the smelting rooms during the summer of 1942 often exceeded 110 degrees. Workers wore thick wool protective gear to prevent burns from molten splatter, increasing the risk of heat stroke. Yet, the lines didn't stop. They couldn't. Production numbers skyrocketed. In May 1942, the secondary aluminum industry, powered by scrap, produced 38 million pounds of ingot. By December, that number hit 54 million pounds per month. Meanwhile, Reynolds' new primary plant at Lister Hill, Alabama, achieved the impossible. Breaking ground in late 1940, they poured their first aluminum ingot on May 18, 1941, just 6 months later. A process that normally took 2 years was compressed into 180 days. They built the factory while designing it. Engineers sketched blueprints in the morning for construction crews to pour concrete in the afternoon. When structural steel for the building frame ran out, Reynolds bought used oil derricks from Texas, cut them down, and used them as columns. By late 1942, the panic began to subside. The combination of frantic recycling and the rapid construction of new capacity by Reynolds and ALCOA had bridged the gap. The shortage that threatened to ground the Air Force was being strangled by American hustle. The true test of this recycled and newly minted aluminum came in the skies over Europe and the Pacific. The metal that once cooked Sunday roasts was now flying at 400 miles per hour. Consider the P-51 Mustang. It was the game changer of the air war. Its airframe was a masterpiece of aluminum engineering, utilizing a laminar flow wing skin that required exceptionally high-quality alloy sheets. The skin had to be perfectly smooth. Any ripple or imperfection caused by inconsistent metal quality would destroy the aerodynamic advantage. On January 11, 1940, P-51s from the 354th Fighter Group engaged the Luftwaffe over Oschersleben, Germany. Among them was Major James H. Howard. He found himself alone, separated from his squadron, surrounded by 30 German fighters, Messerschmitt Bf-110s and Foch, Wolf 190s, attacking a formation of American B-17 bombers. For 30 minutes, Howard fought a one-man war. He dove his Mustang at speeds exceeding 500 miles per hour. At those speeds, the G forces pulling on the wings were immense, exceeding 8 Gs in the pullouts. The aluminum spars, forged from the very supply chains that were empty 2 years prior, groaned but held. Howard shot down 3 German planes, likely destroyed 3 others, and damaged a 7th. The German pilots were so bewildered by the ferocity and durability of this single American plane that they assumed he was a suicidal madman. When Howard landed, his gun ports were jammed and his fuel was fumes, but the airframe, the aluminum skeleton, was intact. General Adolf Galland, commander of the German fighter force, later admitted the psychological impact of seeing the sheer number of American planes. He wrote that the Allies' ability to replace aircraft losses almost instantly broke the spirit of the Luftwaffe. For every one we shot down, a German pilot noted, 2 more appeared the next day. That replacement rate was only possible because the aluminum supply chain had been fixed. The recycled pots of 1942 had become the wing spars of 1944. The scrap drives provided the critical buffer stock that allowed the P-51s, the B-17s, and the B-29s to be built without delay, while the massive new mining infrastructure caught up. In the Pacific, the impact was even more stark. The Grumman F-6F Hellcat, built with heavy aluminum armor plating around the cockpit, became known as the aluminum tank. It was rugged enough to absorb punishment that would disintegrate a Japanese Zero. The Zero used a super, light extra, super duralumin that was prone to corrosion and lacked armor protection to save weight, because Japan lacked the aluminum abundance to build heavy, survivable frames. American pilots survived because they were wrapped in a cocoon of excess metal. By VJ Day in 1945, the numbers were staggering. In 1939, the U.S. produced 327 million pounds of aluminum. In 1944, that number peaked at 2 billion pounds, a 7-fold increase in 5 years. The civilian scrap drives alone collected over 50 million pounds of aluminum between 1941 and 1943. While this was a fraction of the total needed, it came at the single most critical moment, the gap years, keeping the foundries hot when ore shipments were being sunk in the Atlantic. Reynolds Metals emerged from the war not as a foil salesman side project, but as an industrial titan, producing nearly 450 million pounds of aluminum annually by war's end. The monopoly was broken forever. The price of aluminum dropped from 20 cents a pound in 1939 to 15 cents by 1945. Despite inflation, this abundance changed the world. Before the war, aluminum was a semi-precious metal used for jewelry and high-end cookware. After the war, with massive excess capacity and cheap prices, it became the metal of the modern age. The aluminum siding on millions of post-war suburban homes. That was made possible by the rolling mills built for bomber wings. The aluminum beverage can, introduced by Reynolds in 1963, that was the direct descendant of the technology developed to package rations and ammunition. The Boeing 707 and the start of the jet age, built on the metallurgy perfected to make the B-29 Superfortress. Even today, the legacy of that desperation drives the industry. The 747 you fly in, the Ford F-150 you drive, the MacBook on your desk, they all utilize the 2000 and 7000 series aluminum alloys that were standardized and mass-produced to defeat the Axis powers. Most importantly, the recycling infrastructure created in the panic of 1942 never went away. Today, nearly 75% of all aluminum ever produced in the history of the United States is still in use, recycled over and over again. The energy savings are massive. Recycling aluminum requires only 5% of the energy needed to refine it from ore. The pot and pan drives taught America the value of the circular economy long before the term existed. Let's return to Ensign George Gay. Floating in the Pacific in June 1942, he was eventually rescued by a PBY Catalina flying boat, another aircraft made possible by the ramping aluminum supply. He survived the war, became a commercial pilot for TWA, and flew for 30 years. He passed away in 1994, but there is a twist to his story. The Japanese carriers he watched burn, the Kaga and the Akagi, were doomed not just by American bombs, but by their own construction. Their damage control systems were antiquated. Their fuel lines were brittle. They lacked the redundant, heavy-duty structural reinforcement that American ships possessed. Japan, resource-starved, had cut corners. America, resource Rich thanks to men like Reynolds and the millions of families who emptied their kitchens, built machines that could take a hit and keep fighting. It reveals a fundamental truth about the American victory. It wasn't just won by courage, it was won by capacity. It was won by the ability to turn a crisis of scarcity into an avalanche of abundance. Every time you crush a soda can and toss it in a recycling bin, you are participating in a ritual that saved the free world. You are repeating the act that mobilized a nation. You are touching a material that, in the dark days of 1942, was more precious than gold. The fighter jets may be gone, scrapped or sitting in museums. But the metal is still here. The atoms of aluminum that were once a grandmother's saucepan, then a Mustang's wing, might now be the phone in your pocket. It is the enduring, silent witness to the time when America scraped the bottom of the barrel and found the strength to fly.